Let's talk about Spark Streaming, another technology built on top of Spark Core. Very exciting one, very powerful. The idea is that it can process streams of data as it comes in real time. So, unlike the Spark jobs we've run up till now, that where you just run them and they're done, Spark Streaming jobs can run forever. Well, a long time anyway. So, for example, let's say you have a fleet of web servers for a big website that you're responsible for. Those things are broadcasting log information all the time at a massive rate, right? Spark Streaming can actually let you throw a cluster at that, ingest that data as it comes in, transform it, keep totals of things as you go, maintain sessions, whatever you need to do, write it off to a database, anything, and actually keep up with it in real time. So it's not like a batch approach where you're taking all the data for a day and crunching it and getting a result. It's taking the data as it comes in and processing it as it comes in. Okay. So an example, besides logs for a web server, maybe an Internet of Things application. You have a lot of sensors out there that are broadcasting sensor information at some massive scale. Spark Streaming might be a way to ingest all that information in real time and actually react to it quickly, as opposed to some daily batch that you might run. Now, Spark Streaming is a little bit different from something like, say, Apache Storm, in that it's not really streaming technically. What it really does is it breaks down that data into individual chunks that you process together as small RDDs, okay? So you're not actually processing data one, byte at a time as it comes in, but you can process it, say, 1 second at a time. That's a more typical scenario. So technically speaking, Spark Streaming isn't really streaming. It's dealing with what we call micro batches, but for the vast majority of applications, the distinction doesn't matter. And you can configure Spark Streaming to talk to any variety of data sources. So you can just listen to a port that has a bunch of data being thrown at it and ingest it pretty easily. Or you can connect to other systems like Amazon Kinesis or Kafka or Flume or other technologies that are used to aggregate data and broadcast it, publish it on a network at a large scale. There are add-ons you can get for Spark Streaming to connect to all of these things and more. The other good thing about Spark Streaming is it's reliable. So it has a concept of checkpointing where it can actually store its state to disk periodically, and depending on what kind of receiver you're using, what kind of data source you're using, it might be able to pick up right where it left off in the case of failure. So it has a very robust mechanism for actually dealing with failures, and if a node goes down, if the whole system goes down, if it can recover from that. It can pick up where it left off and just keep on going, which is extremely important whenever you have a system that's running 24/7, right? It means you get woken up less often at night for random problems. So just like Spark SQL had the concept of a data frame built on top of an RDD, Spark Streaming gives you the concept of a D stream. And basically, this is a collection of RDDs that embodies the entire stream of data. The cool thing is that you can actually apply a lot of the same functions to RDDs to D streams. So you can say things like flat map to a D stream and just have this mapping operation happening all the time as this data comes in. But you can also break that D stream down into its individual RDDs and process the results one chunk at a time when you're done. Let's see how that works. So, just setting things up, basically you set up a streaming context instead of a normal Spark context, and you pass in how frequent you want the batches to be. So this is saying I want to create a streaming context that processes data 1 second at a time. I can then connect that to a socket. Let's say I want to listen to port 8888 on my own computer and just listen to any data that's coming in on that port as a simple example. And what I could do is just filter that for anything that contains the word error. Let's imagine that it's Apache log messages or something, and I'm interested in error lines, and I want to print those out. So these 4 lines of code is all it would pretty much take to listen to a stream of log data that's being broadcast on some TCP port and print out any error messages that come up. Okay, and it's a little bit more than those 4 lines. You also need to start the actual process and wait for its termination when you're done, but yeah, whatever. All right, so if you want to aggregate data, you can do that too. You don't have to deal with 1 second at a time. You can actually add things up over time too, and that's where windowed operations come in. So there's operations like window and reduce by key in window that you can use to actually aggregate over a larger period of time. So say you want some moving total over time. Say you want to get the most popular thing purchased over the past 24 hours. You could set up, for example, a window of 24 hours and say, I want to aggregate information over that time period. So that's going to be updated with each batch that comes in, which might be a much shorter time period, like 1 second, but keep track of things over the past, hour, 24 hours, whatever you need to do. So Spark Streaming makes that very easy to do. It also lets you maintain state associated with a given key that is persistent. So for a good example is web sessions. Let's say that you identify a session by an IP address over some period of time, like 20 minutes from the same IP address is defined to be a session. You can actually define a session object that gets associated with that key over time and automatically gets expired after a certain period. So let's just look at a simple example. Spark streaming is a very big topic in and of itself. I actually have a whole course on it. So if you want to learn more, watch the bonus lecture at the end and I'll tell you more about that. But let's start with a simple example that is kind of a fun one. What we're going to do is connect to Twitter and actually listen to live tweets in real time. And we'll keep track of the most popular hashtag as we go. So let's talk about how that works. So the first thing we need to do is to get a Twitter developer account. We can't actually connect to Twitter data without registering ourselves with Twitter. But fortunately, that's pretty easy to do. You just need to go to apps.twitter.com, give them some basic information about yourself, and it will give you back the authentication tokens that you need. So I'll walk you through all this when we actually run this interactively. And if you're not comfortable giving your information to Twitter or you don't have a Twitter account, fine, just watch me do it. But it is a fun thing to run and actually run yourself. So once we get that, we're going to just put that information in a twitter.txt file, and we're going to write some code to parse that in and actually set up our Twitter receiver to connect to Twitter directly using this authentication information. After that, we get into the meat of the script itself. So what we're going to do is create a stream, and there's a Twitter utils function in the examples of Spark that we can use to do that. So that's going to give us back a D stream of tweets. We are going to map that to just extract the text field. So every tweet is like this structured piece of data that contains the text of the tweet itself, who sent it, where it was sent from, and all sorts of other stuff. All we care about is the actual text. So we're going to extract the text and put that into a new D stream called statuses. So let's imagine that people are talking about Boaty McBoatface. It's kind of a silly example, but if you don't remember it, this was like an internet thing a while ago. Basically, some navy somewhere in Europe held an online contest to name their new ship. And of course, the internet being what it is, came up with a bunch of goofy stuff, and the winner ended up being the name Boaty McBoatface. And of course, Twitter was all a Twitter about this at the time. So let's imagine that people are talking about Boaty McBoatface. So we have 4 tweets that come in. Vote for Boaty McBoatface, vote for I like big boats and I cannot lie, which was also on the top results. What iceberg or Boaty McBoatface all the way. So we're going to look for the most popular hashtag that we run across. So at this point, our statuses, our D stream contains this information, the text of each tweet, one on each entry of the D stream. Okay, so now we're going to split that up into individual words. So we're going to just call flat map on that, and it works just like with an RDD, and we can just pass in this little lambda function to split it up based on spaces. Obviously, you can do something more fancy if you want, like we talked about before. So now we're going to get this new D stream that contains every word of every tweet that comes in. Vote for Boaty McBoatface, vote for. But all we care about are the hashtags, right? So we need to then filter out anything that's not a hashtag. And to filter things out, we use the filter function. So we're going to pass a filter function of word has to start with a hash sign. And if so, it will survive into our new hashtags D stream. So at this stage, we have a D stream that just contains hashtags. And Boaty McBoatface, what iceberg, Boaty McBoatface, etc. All right, now we can convert that into key value pairs, so we can actually count them up. We've used this trick before, so we're just going to map that to tuples, key values of the hashtag itself and the number 1, so that when we add all this up and reduce it, we get to count up all those ones to get the grand total of how many times each one occurred. All right, now how do we do this over a given period of time? Like, we don't want this to keep track of things forever, but that's where windows come in. So we're going to do reduce by key and window, okay? So this is your usual, there's something a little bit extra here. So when we're doing reduce by key and window, to make things more efficient, you want to pass in a function not only on how to combine things together, but also how to remove things, because it needs to take things off as they expire, right? So that makes it a little more efficient. You can actually do it without doing both of those functions, but it's faster if you do it this way. So we're passing in a function for combining things, for removing things, the window time, which is going to be 5 minutes, and the batch and the slide time, 1 second. So basically, every 1 second, it will update a new result over the past 5 minutes, if that makes sense. And what we end up with is Boaty McBoatface is in the lead with 2, and What Iceberg has 1 in our example here. Finally, we can just sort and output the results. So we're just going to sort by the count, which is in the second element, and print them out. And that's what we end up with. And this thing will just chug along forever, keeping track of the most popular hashtags as it runs over the past 5 minutes. So let's actually run it, see what happens.